In this video, we will prove this theorem, derivatives of transforms. For instance, how this equation will be generated. Let's start the proof of this. For instance, we have f of s is equal to Laplace transform of f of t. This is actually given in the theorem, and we have to prove this one. And how we will prove this? Just by taking the derivative with respect to s. Just take the derivative of f of s with respect to s. We will apply derivative over here as well, and also we will open this transform by definition. Now, since there are two variables involved in this equation, so this d over ds will be converted to partial over partial s. So e raised to the power minus st f of t dt. Now just take the derivative of this function with respect to s. So what will be the answer? The answer will be minus t e raised to the power minus s t f of t dt. Now further, just check what we are doing. So this will minus will be out of the integral, so this will become 0 to infinity e raised to the power minus st, and just take t and f of t into the bracket, and if we close this form according to the definition, so this will be happen. Here you can see d over ds f of s. So we can write Laplace transform of t into f of t, which is equal to minus 1 d over ds and f of s. So this is proved now for n is equal to 1. You can see over here Laplace transform of this particular function, that is equal to minus 1 raised to the power n dn over ds and f of s. So in our case here t is 1. If t is 1, then you can say the derivative of f of s with respect to first derivative, you can say. Now continuing this way, if we continue this procedure, if we take again the derivative of this function, for instance we have minus 1 out of the integral. If we take another derivative of this function, so we have f of s and then derivative of this transform t f of t dt. Now what will we do? Now you can check minus 1 d square over ds square f of s, which is equal to Laplace transform of t f of t d over ds. If we apply the definition of Laplace transform, that will be 0 to infinity e raised to the power minus st t f of t dt. Similarly, just take the partial derivative of this function e raised to the power minus st t f of t as it is, and we have 0 to infinity minus t e raised to the power minus st t f of t dt. Then minus will be out of the integral. We have 0 to infinity e raised to the power minus st, and just multiply this t with this t, so it will become t square f of t. So according to the definition, we have minus Laplace of t square f of t, which is equal to, you can say, minus 1 raised to the power 2 d2 over ds square f of s, which is equal to Laplace transform of t square f of t. So continuing in this way, we can conclude that minus 1 raised to the power n dn over dsn of f of s, that will be equal to Laplace transform of t raised to the power f of t. So this is the proof of this particular derivatives of transform.